Hello, everyone. Our group explored, analyzed, and contextualized the spread of COVID-19 in the US.
In order to understand how COVID-19 spread throughout the US, we wanted to look at a variety of questions. We wanted to understand how the hotspots moved over time, how vaccinations have affected the spread of COVID-19, how mask mandates and public policy may have affected the spread of COVID-19, as well as variants. And we wanted to also compare the trends to the global community. In order to understand the hotspots of COVID-19 in the United States, two approaches were used. The first approach was animated heat maps, where you plot the total number of cases and deaths in a state and map it to the color. Um, this was complemented with cluster analysis, where each observation is grouped together based on how similar it was in terms of case and death increase. And based on this analysis, we managed to discover that we can categorize the spread of COVID-19 in the US into two major waves. Wave one was centered in New York with a high case to death ratio with eventual increases in the South. Wave two, the entire country saw an increase almost all at once, which may have coincided with Thanksgiving travel. Some major states, California and New York, saw exceptionally high increases during the worst times of the pandemic. Texas, Florida, and Illinois were also pretty bad as well.
When analyzing vaccination administration by states, there were four with notably higher deployments: California, Florida, New York, and Texas. With metropolitan density impact travel points, this could indicate that inventory was prioritized differently across states based on eligible populations. Implementation through the manufacturer scope shows that Pfizer and Moderna, though both double doses and requiring more patient-provider coordination, still dominated. Here, we can see that the percentage getting vaccinated dramatically skyrocketed since first date of availability. Conversely, the positive cases began to shrink while death counts were incomparable. The top right graph shows the most recent negative correlation between vaccines and death counts. Next, a death rate feature was created to look into the mortality of the virus. Lastly, there was a stronger correlation between positive cases and death, as expected. Vaccines should primarily slow the spread of the virus and implicitly lower death counts.
Even though unmasked states have a slightly higher death toll, the difference is not significant enough to make a statement regarding mask mandates. In the graph on the top right, Texas's death rates roughly match the mean, even after its mask mandate was removed. It is also responsible for a large portion of the population of the states without mask mandates. So the fact that its death numbers are so similar to the national average contributes to the trend in the analysis. So even though unmasked states have eventually higher death tolls, as evidenced by the graph on the bottom right, statistical analysis indicates that it is not significant enough to draw a conclusion.
Regarding variants by state, Michigan had the highest proportion of the B117 variant, which originated in the UK. South Carolina had the highest proportion of the B1351 variant, which originated in South Africa, with a general cluster on the East Coast. California had the highest proportion of the B1427 variant, as it originated there, resulting in a cluster on the West Coast. Lastly, Illinois had the highest proportion of the P1 variant, which originated in Brazil. Overall, the UK variant was the most common in the US. The spread of these variants were due to travel, indoor dining, and hotels.
Global trend analysis was performed by looking at the 6 World Health Organization divided regions: the African region, region of the Americas, Southeast Asia, Europe, Eastern Mediterranean, and Western Pacific region. Both new case count and new death count per day was analyzed after normalizing the data to the population size. The dataset used included many countries for each region, so the daily count was also averaged to plot. As seen by the top two graphs with the global region comparisons, the Americas have the largest peak in new cases a day, while the death rate due to COVID-19 has a more random distribution of peaks, with regions like Southeast Asia having peaks earlier and Europe later. The US was then compared to the countries from each region with the highest new case and new death counts. As seen in the bottom two graphs, the US has the most significant peak in new cases near the end of 2020, but other countries such as South Africa and Brazil have also had significant peaks in new deaths. In conclusion, then, we have seen two major waves starting in cities and moving everywhere else in the US. The spread of COVID-19 can be explained by vaccinations and variants, but not necessarily mask mandates. And a global comparison demonstrates that the US has exceeded other countries in case counts and deaths.